Okay, this section is a little unusual in the sense that we're not actually going over any trigonometric theory here, but it's a brief section on just how to use a calculator, because that is an essential part of working out some of the problems we're going to see. Of course, we all might have different calculators. The calculator that I will be using through these demos is the TI-30XS Multiview. The features that you see on this calculator are pretty common on a lot of calculators. I do recommend that you pull out whatever calculator you plan on using for this course and follow along the calculations as we do them so that you can test to see that you're actually putting things in correctly by comparing the outputs with my output. If you're unsure about how to use a particular feature on your calculator, you can always reach out to me, make an appointment to one of my office hours, and we can talk, and you can show me your calculator and I'll explain how to use the various features. If you don't have a scientific calculator, there are plenty of good ones online for free. My favorite one is the Desmos Scientific Calculator, and it's the one I've been using a few times in our lectures, so you'll probably recognize it when you see it. Okay, the first thing we should do is make sure that we're working in the right mode for trigonometry. And there are two modes that we're going to be working with this semester, degree mode and radian mode. And as of this moment, we have only talked about angles in degrees. So radian angles will come in chapter 3. It's only a few sections away now. But for now, let's make sure we're working in degree mode. In many calculators, you can tell because there's the word deg in the top corner, or sometimes it's just a letter D. You can change the mode by pressing mode and pressing to the right or the left and navigating these different options. So if we wanted radian mode, which we will want a little later in the semester, we would highlight it and then press enter so that it's selected, and then second quit. So now you can see it says rad at the top of our calculator because we're in radian mode. So if we were to go sine of 90, it would not be 90 degrees, it would be 90 radians. So it gives a weird answer that we don't recognize. However, if we switch back to degree mode, so make sure degrees flashing, press enter to select it, and second quit. Now if we ask sine of 90, it's going to be sine of 90 degrees, which we know is 1. Okay, so let's approximate cosine of 193.622 degrees. So when you see the word approximate, that usually means evaluate on a calculator. Okay, so let's approximate cosine of 193.622 degrees. So on this calculator, we start by pressing cosine, and then we put in the angle, 193.622. And notice that it automatically opened parentheses when we pressed cosine. We do not have to close them. The calculator will automatically close the parentheses for us, but I will just for fun. There we are. And there's our answer. So cosine of 193.622 degrees is negative 0.97187 blah blah blah. Okay, next let's approximate tangent of 68 degrees and 43 minutes. All right, here we have tangent of 68 degrees, 43 minutes. So let's press tangent, and it opened the parentheses automatically. Now 68 degrees and 43 minutes, we can sort of simulate that by going 68, that's the number of degrees, plus 43 divided by 60, because 43 minutes is 43/60ths of a degree. Now because the parentheses were opened, this entire expression will be included in the tangent. So we just press enter, and this time I didn't close the parentheses. And the correct answer is 2.567 blah blah blah. Again, I do hope that you're working these out on a calculator along with me, and that you're comparing your answers with these answers. If you're consistently getting a different result, that means something's not right with the way you're using your calculator. And it's important that we figure out what that is and get it right so that this doesn't mess up your solutions to the problems we're going to see throughout this semester. Okay, let's approximate cosecant. Now, most calculators don't have a cosecant button. They only have sine, cosine, and tangent, which means we actually need to change this problem to 1 over sine of that angle, 35.8471 degrees. And now we can calculate that on a calculator. Note, do not use the inverse sine button, which has a different meaning. It is not 1 over sine. It's a common mistake. So we will actually use that in a few minutes today, but it's not for this purpose. For cosecant, you need to go 1 divided by sine of the angle. Okay, for cosecant, we know that that's going to involve going 1 divided by the reciprocal of cosecant, which is sine of our angle, and that was 35.8471 degrees. So the cosecant of 35.8471 is 1.707 blah blah blah. Okay, let's approximate secant of negative 287. And as before, we'll have to interpret this as 1 divided by cosine of negative 287 degrees. Okay, so here we want secant of negative 287. And we know to start we'll go 1 divided by cosine, which is the reciprocal of secant. And now we need to input negative 287. Now, a common mistake here is to use the minus for negative, minus 287. And it can be very frustrating because you'll get this syntax error here. It's very confusing. So let's clear out of that. And it tells us that the syntax error occurs right where the minus was. So indeed, many calculators have an alternate negation button, which is down here at the bottom, and it's like a minus in parentheses, and that's the one we want. And notice it's a little bit of a different shape, and it just is what it is with calculators. So that one worked, and that is the correct answer. Secant of negative 287 degrees is 3.420 blah blah blah. All right, let's approximate cosine of 13 degrees minus sine of 16 degrees. All right, for cosine of 13 degrees minus sine of 16 degrees, well, we could certainly go cosine of 13. And the problem is, if we just go minus sine of 16, we now have to play the parentheses game here a little more carefully than we are, because notice the cosine open parentheses, but we never close them. So this is actually cosine of the entire 13 minus sine of 16, which is definitely not what we want. So let's just start over, and we're going to go cosine of 13, and let's close the parentheses. That tells the calculator, okay, we're done with the cosine of 13, and take that and subtract sine of 16. And that is the correct answer. Okay, another thing you can do is you could go cosine of 13 and then press enter, and we have our temporary answer. And now we'll just press the minus, and what it does is it loads up the previous result as ANS for answer, and we're going to go our previous answer minus sine of 16. and we get the 0.6987 like we did before. Okay, let's spend a moment talking about the inverse trigonometric functions: inverse sine, inverse cosine, and inverse tangent. Now, loosely speaking, these three functions undo the operations of sine, cosine, and tangent. So, in other words, as sine, cosine, tangent are functions that take an angle as input and produce a ratio as output, the inverse trig functions take a ratio and tell you what angle that came from. So, for example, we could use a calculator to evaluate sine of 10 degrees. Okay, so let's calculate sine of 10 degrees, which is 0.1736 blah blah blah. So therefore, inverse sine of this particular ratio should give us 10 degrees. And now we want to get the 10 degrees back. So we're going to go second to access this layer of green functions, and we want the inverse sine function, which is that guy right there. And now we actually want to load up our previous answer. So one thing you could do is you could just start to type it, 0.17, etc. I'm not going to do that. The best thing to do is you can go second, and down here there's a little ANS button, and that loads up the previous answer. So this is like, what's the inverse sine of all the digits of the previous answer? And look, we get 10 as an answer. So inverse trig functions go the other way. Okay, well, the problem with ANS is that it only gives you the most recent number. Like if we went 5 plus ANS answer, it'll be 5 plus 10, and of course that's 15. But what if we wanted that 0.173 in some other part of our calculation? Of course, you could just write it on a piece of paper and then put it in manually each time you needed it. But these arrows right here are pretty nice. So what if I wanted inverse cosine of that 0.173? So we've loaded up the inverse cosine, and now I'm going to go and use these arrows, and you can navigate. I'm just pressing up each time, and what it does is it walks me through all the different things we've punched in. So let's go and pull up that guy, that 0.17, and I'm just going to press enter, and what it does is it manually loads it into our entry here. So if you go back, you can see there's our inverse cosine of the 0.17. Okay, well, let's press enter, and we get 79.99999. That's basically 80 degrees, right? Which is actually the complement of the 10 degrees that we started with. Okay, now there's a lot more nuance to these functions than we're going to be talking about here. Namely, you could choose an angle in the second quadrant whose reference angle is 10 degrees. For example, sine of 170 degrees will also produce that ratio. However, inverse sine of the ratio will get us back to 10. So it doesn't faithfully go back to the original angle. It doesn't know what original angle you were working with. It just knows to go back to the simplest version of the angle. So that would be 10 in this case. We're going to study these functions and their intricate behaviors in depth when we get to chapter 6. Okay, but what we do understand about these functions is we can answer a question like this. Find an angle in the first quadrant whose cosine value is 0.92118541. And the way we would answer that is by saying, well, theta is inverse cosine of 0.92118541. Okay, here we need inverse cosine of 0.92118541. And so our answer is 22.8999 blah, blah, blah. Okay, similar problem here. We want to find an angle theta in the first quadrant that satisfies cotangent of theta equals this particular ratio. Now, the problem is we do not have a cotangent inverse button. So if we're intending to use a calculator, which a normal human would want to do here, we can't just say, well, this is inverse cotangent of 1.4466474. While that's a true mathematical claim, it's not going to help us actually do the calculation. Now, a really common error here is to say, well, theta must be 1 divided by inverse tangent of 1.4466474. And this is incorrect. That will give you the wrong answer. Before converting to the inverse version of the trig function, you should take this statement and first convert it using only sine, cosine, and tangent. So we know that if cotangent of theta is 1.44 stuff, then tangent of theta is 1 over 1.4466474, and therefore theta is actually inverse tangent of 1 over 1.4466474. So the reciprocal of the ratio occurs before you take the inverse tangent. Okay, for this one, we know we're going to go inverse tangent of 1 divided by 1.4466474. And so the correct answer is 34.6543 blah, blah, blah degrees. So the answer is 34.6543, and we're out of space, so there we are. Okay, well, this seems simple enough. We know that we can write theta as inverse sine of the square root of 3. So let's use our calculator. Okay, well, it looks like we need inverse sine of the square root of 3. Oh no, what happened? Okay, well, the reason why this was a problem is because, and you may have noticed this before we even started, that this is an impossible statement. Right? Remember that sine of theta must be between -1 and +1. And radical 3 is about, well, it's about 1.7. So that's out of range. And so this has no solution. All right, so that completes this section on using your calculator. But I'd like to end things with one final generic calculator tip. So sometimes you might be doing a calculation, like say you want to get the square root of 20, and you get the simplified version of root 20, which is 2 root 5 out, but you might actually want like a decimal value, right? If this were the answer to a specific question, you wouldn't go to the hardware store and ask for 2 root 5 liters of paint. So in this case, we have this little button right here, which is like 2 back-to-back arrows, and it kind of tells the calculator, look, convert the answer to decimals, okay? And you can press it again to convert back to an exact form. So most of the time in this course, we prefer the exact form of an answer, But when we are working out a specific application problem where there's physical lengths involved, for instance, in that case, we're probably going to want decimals.